Jimmy, I was wondering if you could share a story, war story, where lack of version control for data pipelines caused the model to melt.
Yeah. So this one I've experienced firsthand. It's more of an oddity, but you can extrapolate some of the potential issues that would go wrong. So in the case of speech recognition, digits are a really interesting thing. Do you, like in transcripts, for example, if you receive a bunch of transcripts and audio pairs, which is your training data, from someone or from either an organization that curates stuff for you or that you do in-house, and you need a lot of that as well. But like standardizing how people write things, like in the financial markets, like $1, or dates are a particular one, like 2022, or like there's multiple ways to say it that all map to a single thing, or can all map to a single thing, or do you represent it as the spoken version, like 20 spelled out, 22 spelled out, because you're seeing more like speech to character kind of data in that scenario. So there's some interesting things that you can get just from a data perspective. Inspecting all the data is too much. If you're getting thousands of hours of audio coming in with transcripts, you can't spot check everything. Essentially, the war story here was we were doing kind of full end-to-end deep learning stuff, like sequence to sequence type modeling and those kinds of things back when 5 years ago or something. And actually longer than that. Wow, that's getting scary thinking how far back that was now. But essentially what we received a bunch of data and just ran our pre-processing on it. And we were using basically converting digits to the spoken representation, spelled out 2022 or something like that. And so what was really interesting was obviously no errors in our model. This pre-processing is happening on like this guy gets into Abe's territory as well, potentially. This is happening on your training data, this is happening on your testing data. So you have this processing that goes across everything and using this data for however long, not seeing any issues because consistent releases of models. And then one time we were inspecting something, or we had a new piece of data that we were trying to see how well we could do on this one audio clip, for example. And the person said, oh, back in 2016, and we saw that the model had spelled out 2016. And we're like, this is odd. Like we would expected, like they said one thing and our model inserted a lot of words that weren't there. And it's also a character-based model at this point. And so to insert that many letters in a sequence to sequence model is pretty interesting. And so then we had, at that point, we're like, okay, something's going on in our data somewhere. How do we find this? And how much of it is present in our data? Because we knew that we had run these transformations over all of our data, but now we didn't know when this new data, or when that new data, what new data actually impacted. When did something come in where everything changed, and how many releases of the models had happened before we found this out? Because it was the same pre-processing as you should, like same pre-processing on your input data, on your training data and testing validation data. But yeah, we were seeing the model it's going to learn whatever it can from the data, and learning the transformation of the spoken word 2022, for example, to 2022 was really interesting, that a deep learning model could learn that and just know it. So so that one's the one where we found, oh, like the version control, we can't just like version the releases of the data sets and stuff. We also need to know what's changed and be able to compare these things and standardize like when something happens, and be able to like backtest and do other kinds of things on previous versions of stuff, because it's always going to change. You're always going to find something new. You're always going to find a bug in your model, but you need to be able to trace it and figure out how to change it.